right, y'all. So we're going on to 8.3, and this is polynomial division, but we're going to do a little reteach before we actually do this. So yesterday, you were graphing and graphing polynomials, and so to do that, you have to have your zeros. So I'm going to give you just some random problem here. So if I have this, before I can graph this, I have to find my zeros. So to find my zeros, I have to do trial and error, which I can't do because this is x to the fifth. So I want to go in and do greatest common factor. So I pull out an x, and I'm left with x to the fourth minus 13x squared plus 36. Okay, so if I look at this, I know 9 times 4. The addition of this is going to give me 13. So those are going to be my two factors. So I ended up with x squared minus 9 and x squared minus 4. And now we keep going, and we keep going because we see we have two difference of squares. So I have x plus 3, x minus 3, x plus 2, x minus 2. Okay, so we can go in here, we can solve this, we can graph this, and we're good, right? So what happens when we have something that looks like this, and this doesn't factor the way that we want it to factor? Well, we have another method for solving this, and this other method is called synthetic division. So if you know one of your factors, so let's go back. So these are all factors. So I have 1, 2, 3, 4, 5 factors. And it's because it's a big polynomial, degree of 5, so I'm going to have 5 factors. Okay, so if I have something that looks like this, this tells me I'm going to have 3 factors. Well, if I tell you here is one of the factors, then what I can do is I can use division to get rid of it. So if I have a big number, so let me just put a number up here, like 36 over, I don't know, 18. And if I tell you that one of those factors, so just one factor is 2, I could divide this by 2, and I could divide this by 2, right? And what I get here is 18 over 9. Well, this keeps reducing. I could do it again, right? And I can say, all right, well, another factor is 3. So if I divide this by 3 and divide this by 3, then what I get is 6 over 3. Okay, well, guess what? Another factor here is 3 again. So if I divide this by 3 and divide this by 3, then I would get 2 over 1, which is just 2. Okay, so technically, we don't ever do this, but technically this is what we did. And we said, okay, this is a factor, and this is a factor, and this is a factor. So if I wrote this out, I could say 2 times 3 times 3 times 2 over 2 times 3 times 3. So here's what I have in the denominator. Okay, so all of this would reduce out. This was what we did in elementary school when you did something called prime factorization. All right, and so then we said, all right, this cancels, and this cancels, and this cancels, and what we're done is we're left with 2, right? And that's what we set up here, that our answer here is 2, right? And we know 18 times 2 is 36. So you could have just gone right to the very beginning and said, all right, well, we divide both of these by 18, and we're going to get 2. Now, the reason why I'm showing you this is because of what we're doing now. So we have all of this. Now remember, we started here, and I said, what if I told you 2 was a factor? Well, now what I'm going to do is I'm going to tell you that x minus 4 is a factor. So what we're going to do is we know that in the big picture here, one of my zeros is going to be x minus 4. We know that because this is, I'm telling you this, okay? And so what we're going to do is we're going to do something called synthetic division. So I'm going to show you how to set it up and then how to do the math. So stick with me on this. So just watch me for a minute and then pause the video and then go write down everything that I have written down. All right? So when you did long division, you would say something like 3 divided into some number, 4, 8, 9, right? And we would say 3 goes into 4 so many times. So this is how we would set up long division. Well, how we set up synthetic division is we first have to find the 0. So we know that the 0 here is going to be 4. So I'm going to write a 4 over here. And I'm going to put it in this little box. And this says that my 0 is 4. It is not the factor. you have to use the 0. So the 0 is 4 here. Now, I'm going to take my polynomial and I'm going to make sure that all of my terms are accounted for. So I have 3 x's, 2 x's, 1 x, and no x. So this is in standard form and this is good. So because this is good, I'm only going to write down the coefficients. I'm only writing these coefficients down. So I would write 2, -3, -18, -8. Okay, write that down. Now, our very first term here is 2. We don't do anything with the 2. We just bring this 2 down and put a 2 right here. And now we say 2 times 4. 2 times 4 is 8. And all of these are going to be added. So 8 minus 3 is 5. Then I do it again. 5 times 4. 5 times 4 is 20. 20 minus 18 is 2. And really, I'm not subtracting. I know I'm saying subtraction, but I'm adding. So I have -18 plus 20. Okay? Then I do it one more time. 2 times 4 is 8. 8 minus 8 is 0. When you have this number as 0, it is a factor. So what I have now is that, yes, this is a factor. So I can take this and I can simplify it. So this is what it looks like. I just said x minus 4, I factored that out. And what's left is, since I got rid of 1x, remember I got rid of 1x up here. I know we don't use it over here. We get rid of the x's and we make it just numbers. So because of this, I'm going to get rid of one of these x's. So I'm going to use these numbers. So now what I have is 2x squared. It's not because of this 2, it's because of this 2. Now technically it's going to be the same one, and you're going to see how this works here in a second. So if this was one of my x's right here, I got rid of 1, so now this x cubed becomes x squared. All right, this is a positive number. So I now have plus 5x plus 2. All right, so if this was a third degree polynomial, then this makes this x squared, this makes this x, and this makes this just your constant. So here's what I have. All right, so if yes, this was a factor. That was the question, is this a factor? Finish factoring, which means I'm going to do trial and error by just this guy right here. So I have my first factor, which is x minus 4. And now I know here I have 1 and 2, and here I have 1 and 2. So my other two factors are going to be x and 2x, and then I have plus 2 plus 1. So 4 plus 1 is 5. So these are my factors. Now, I could go up here and I could try to factor this by grouping and see what I have, but you're going to see here in a minute when we end up with more than 4 terms and we can't use grouping anymore, it looks like this. So if I was to keep going on this, I would say, okay, I have a 0 at 4, and I have a 0 at -2, and I have a 0 at -1/2. And if I go up here, I know this is positive odd, so it would look like this, and then I can put my zeros on and I can graph it. All right, let's keep going. Let's try this. So this says, is x plus 4 a factor? So here, remember, I have to find my 0, and my 0 is -4. So in my little box over here, I'm going to put in -4. Now, I have cubed, squared, x, constant. So I'm good. So I'm going to write just the coefficients. So 2, 3, -18, -6. All right, remember the first one just comes down. So I bring the 2 down. And then I'm going to, remember I'm adding, so I'm going to multiply 2 times -4, so -8. I add this up, I get -5. -5 times -4 is 20. I add this up, I get 2. And here I have 2 times -4 is -8. And if I add that up, I get -14. All right, so remember, if it's a factor, this has to be 0. This is not 0. So, is this a factor? No. So if yes, finish factoring. Well, it's not, so we can't finish factoring. Now, really what I have here is this is like saying I have a remainder. If I was to go back and actually solve this problem right here, and you get down to the bottom and you have some number that's left right here, like in this case, let's say it was negative 14, we would say that this is a remainder. Well, if we have a remainder, it can't be a factor. All right, let's try this one. So what's my 0? My 0 here is 2. So I'm going to start with 2. Now, be careful. I have x to the 5th and then x to the 3rd. I don't have an x to the 4th term. So I have to add 1. So I start with 2. My x to the 4th term is missing, so I'm going to just make a 0. My x cubed is negative 3. Uh-oh, my x squared term is missing, so I have to have another 0. And now I have negative 18 and negative 4. So let's check this. This is x to the 5th, 4th, 3rd, yep, 2nd, 1, yep, constant. So make yourself a note. You have to have these placeholder zeros in here, or it's not going to work. We bring down the 2. 2 times 2 is 4. Now, I know we have a 0 there. We're going to treat it just like normal. So 0 plus 4 is 4. Remember, we're adding. 4 times 2 is 8. So this becomes a 5. 5 times 2 is 10. We're adding. So I keep this as 10. 10 times 2 is 20. This becomes a 2. 2 times 2 is 4. And this is a 0, which is what I wanted. So this is a factor. So is this a factor? Yes, it is. And I'm going to go ahead and write what the rest of this is right now. Okay? So here's what this looks like. So I have one factor that's x minus 2. And remember, we got rid of a 0. So I changed this. So if this was x to the 5th, this is now x to the 4th, x cubed, x squared, x, and my constant. So all of my numbers here are positive. So I would write this as 2x to the 4th plus 4x cubed plus 5x squared plus 10x plus 2. Now, it didn't ask you to do that on this one. It just asks, is it a factor? But I think it's good to be able to go back and look at this. All right. So we have one more here. We're going to check this guy. So we're going to check this at negative 1. Is it a factor? So that's my 0. I start with x to the 6th. So I have 6th, 5th is a 0, 4th is a 0, 3rd is 2, 2nd is a 0, x is a 1, negative 2. So I'm going to check it. 6, 5, 4, 3, yep, that's right, 2, 1, constant. All right, so again, got to have the zeros in there. So if I bring this down, 1 times negative 1 is negative 1. Bring down my negative 1 because I'm adding. Negative times negative is positive. Bring this down. Positive times negative is negative. Now I'm adding, so I have 1. 1 times negative 1 is negative 1. Negative times negative is positive. This becomes a 2. 2 times negative 2 is negative 2. So when we get all the way to the end here, I end up with negative 4. This is not 0. So we did all this work, and this is not a factor. Doesn't work. Okay, now I want to show you something because let me find one here that's going to work. I'm going to make something up. You know what happens when I make something up? Sometimes it doesn't work. So stick with me. Let me see if I can find one real quick that's going to work. All right. So I'm going to give you this polynomial that says 4x plus 20 minus 5x squared minus x cubed. All right. So first thing that I want to do is I want to rewrite this guy so that it's in order. Because if you remember what we did when we put our coefficients down, this has to be in order, right? So I'm going to rewrite this, and I'm going to say negative x cubed minus 5x squared plus 4x plus 20. So now I have it in order. Okay, and what I'm going to do here is I'm going to tell you that x plus 5 is a 0. All right, so if I know x plus 5 is a 0, or is it, sorry, not a 0, it's a factor. If I know that this is a factor, I'm going to put my negative 5 here. I'm going to put all my terms. So 3, 2, 1, constant. So I have negative 1. Negative times negative is positive, so this is a 0. 0 times anything is a 0. And then I have 4 times negative 5 is negative 20. Okay, so that checked out. That worked. That was golden. All right, so now I'm going to tell you that x plus 2 is also a 0. I don't have to go back to the beginning and start again. All right, so if this is a factor, which we proved it was a factor, and I said, okay, you know what? I'm going to give you another one, and that other factor is going to be x plus 2. I'm going to just start right where I ended. I'm going to do it again. So I have negative 2, because remember, I have to do the 0. So I have negative 1. So negative times negative is 2. So I add this up, and now I have 2 times negative 2 is negative 4. Well, this is my 0, so that one also worked. Now, if you were trying to find all of your zeros, let's look at this. Look at what happens here. So if this was x cubed, when I did it the next time, that would make this x squared. So what this one ends up being is just x. Remember, every time you do it, you get rid of an x. So the first time this was x cubed, then it's x squared, and now it's x. So what I have here is I know my factors are x plus 5, x plus 2, and now negative x plus 2. And those are all of the factors of this polynomial. Okay? So let me show you something. This was an exact problem that I pulled from our notes from the other day. It's this problem right here. And what we did in this problem the other day is we solved this by grouping. And when we solved this, this is what we got. X plus 5, 2 minus x, 2 plus x. Well, here I gave you 2 of those factors, and then we found the third factor. So you can always use synthetic division to find your factors as long as you know one of your factors. Okay? Anyway, I wanted to make sure you saw this and how to do this because I think there's one on your homework where you have to check a couple of different zeros. Okay?